If they switch off your, unmute your mic, please. So, Bismillahirrahmanirrahim. Assalamu alaikum and very good morning, my dear colleagues. Asad, can you please mute your mic? Thank you. Ji, assalamu alaikum. Bismillahirrahmanirrahim. Very good morning. My name is Muhammad Abdur Rafaye and I'm working at Shaukat Khana Memorial Cancer Hospital and Research Center, Lahore, Pakistan. So today I'll go through some of the slides regarding physics perspective of the selection, procurement, and the commissioning of radiotherapy department. So in next 45 minutes to 1 hour, I'll just go through some of my experiences, some of tips, some of tricks, based on certain literature and experiences. I'm not going into the details of the commissioning because everyone knows very well about the commissioning, but certainly what is required and what is needed and what should be addressed while procuring and selecting an radiotherapy equipment and for the commissioning of this equipment. So we'll discuss those things today. So I would say that I have no conflict of interest to declare in neither financial nor otherwise, and I have no financial association or otherwise for this presentation. So when we talk about the equipment selection and procurement, there are certain factors we definitely need to consider, and on the basis of those factors, this equipment selection and procurement comes into its motion. The very first thing is the evaluation of clinical needs. Either we are going to establish a new radiotherapy facility, either we are going to establish a new radiotherapy department in an existing facility, or if we are going to purchase and select an equipment as an add-on within an existing radiotherapy facility. For the purpose of this, definitely there comes a review of the specification and all the purchase equipment. Some of the bits on this list, they are directly related with the physics thing, and some of those are shared with other associated personnel as well. For example, our physician colleagues, as well as the administrators and the purchase department as well. Design and construction of the facility, that's an important bit we'll discuss in next slides. Then there comes a step for the installation of the machine, safety checks, and the initial radiation survey, acceptance testing of the equipment, either it's a CT scanner or it's a brachytherapy machine or a linear accelerator. And then the commissioning of the machine before the clinical use. Establishment of the quality assurance program is very important before putting this thing into clinical use. And then the final report and documentation before the clinical use. Obviously, the training of the personnel and the staff is very important. We cannot run a department and we should not run the equipment if our staff is not trained. So the staff means the physics team, our physician colleagues, and lastly the radiation therapy technologist. So I just saw that there is a request of full screen So I just made it as a full screen, but I'm not sure because I'm sharing two screens. So can anyone please confirm that is still being shared? That's it.
Yes, sir, it's okay.
Thank you. So if we start from the equipment selection, what is an important thing to select an equipment? The first step is the formation of a committee. The committee should comprise a physicist, radiation oncologist, engineer, or if you have an in-house engineer. These three are the minimum personnel required for the equipment selection. You do not need to go through certain formal approvals to create or form a committee within the colleagues in a department. A department can decide who will be the part of this committee, this physician, this physicist, or this engineer. And this committee does not mean that the other personnel working in the department, means the other physics members in the physics team, other physicians in the physician team, and other radiotherapy technologists or the engineers working in the hospital would not be able to suggest anything. No, they would be able to suggest everything, but certainly those within the committee will be responsible for answering all the queries and the questions for the equipment selection. So there should be a committee so that a responsibility can be put to someone to look into all this pathway. So the committee should systematically review what is currently required and what are our projected clinical needs. For example, if we will be doing total body radiation in future, we'll be doing stereotactic surgery or radiotherapy in the future. What is the definition of future? Near future, or maybe after a decade? So all this systematic and careful review should be done by this committee. The committee or those members will be responsible for the review of the deliverables, functionality, all the technical stuff, specification of the equipment, physical and logical, and certainly the cost of the equipment as well. Then definitely there must be a review of the available space. If we are going to buy, for example, a proton therapy, do we have a space available? Are the funds are available? Are the resources available? The support staff is in place, or what else we will be requiring to establish this? And then evaluation of further upgrades, warranties, and the maintenance contracts. Evaluation of the quality of the manufactured services and the technical support, certainly. And then the committee should put a final recommendation. So as I said in the beginning, that this is just an example to form a committee. Obviously, in your institute, you can put anyone else, someone from the administration side, someone from the senior radiotherapy technologist side, someone from the, from engineering side. So, but at least there should be a committee. This is a decision tree. You can find this decision tree in certain AAPM reports. So it's very simple. If we are going to buy a new machine, or we want to buy or to replace an existing machine, so yes or no. So we should at first list the anticipated clinical needs. That's an important thing. For example, if I do not have any expertise, if I do not have resources available with me, so and I'm not sure when am I supposed to start this SRS or SBRT service in my center. So I should think all this stuff. So anticipate if there is an anticipated need, so I must also consider all the associated factors with that clinical needs. So the clinical needs does not come into motion without any associated factors. This is an important thing. Are there any additional equipments those are required? For example, if I'm going to buy a standard LINAC, so I may be requiring a standard CT simulator. and the treatment planning system if I'm going to buy an advanced LINAC. So certainly the associated equipment, which is a CT simulator, that would require an advancement as well in order to compete, in order to get compatible with the linear accelerator. So this associated equipment is also very important. Definitely the quality assurance equipment should be of that level as well. And then certainly there will be a review of all the available choices, different vendors, cost, delivery times, etc., etc. And if it requires a bidding process, it will go through a bidding process, or if it does not require a bidding process, so certainly someone can directly choose a machine based on the factors we have already considered. And if the space is allocated, so the installation can go. But sometimes we end up with a problem that the machine has been budgeted maybe 12 months back, and because of these financial crisis and the price values which are going up and up every day. So for example, if I have budgeted a machine with all associated advanced accessories for certain amount, maybe I may not be able to get the machine in the same price after 12 months or 16 or 18 months. So then definitely there would require a review of this budgeted price and what we can get at that time. Here starts the job of a physicist. The first step is the shielding calculation. If you are going to design a new facility, if you are going to house a machine in an existing facility, certainly there comes a point of shielding calculation. Either we need to review the existing shielding, or we may need to need to have a new shielding design for this upcoming LINAC or radiotherapy unit. The first thing is this shielding design should be based on the vendor specifications, riggings, and the dimension plans. I should not be ending up with shielding calculations for a bunker like where I cannot put my machine after that. So all rigging and dimension plans should be obtained from vendor before starting all these shielding calculations. You can get shielding calculations from vendors, or the site physicist is required to do that. There is always a debate, there is always a question, but please be sure this is an absolute responsibility of the site physicist. There is no second thought about that, because we are the one, once the equipment is installed, we are answerable. We are to justify the radiation survey. No one is going to ask from vendor that you had said that this thickness of wall will attenuate the beam, but you can see that no, we are ending up with those that like this. So PNRA has, our national regulator has nothing to do with the vendors. So we are the one. The institutional head is the institutional head is supposed to ask us, not from the vendor. So certainly we'll ask from the vendor if we have already committed something, they have committed something with us. But this is an absolute responsibility of the site physicist. If we get calculations from the vendors, because many vendors, they do provide shielding calculations, but at the end they always write that the site physicist should verify this. So in any case, we should check, we should review, and we should get it approved. If we are going to design a new facility, so before the start of the construction, we can get acceptance of these shielding calculations from PNRA. Though this may not be required formally at a stage where we are not initiating our licensing process, but certainly once we will start the licensing process, definitely the regulator will require all these calculations. So my point to get this approved before initiating the licensing process, before starting the construction, is that if the regulator has some input or some observations or reservations, we can solve at the moment before starting the construction. Because once the construction is done and the regulators has any serious concerns, so we will not be in a position to undo or redo all those things. And then there is another terminology, which is the future capacity. For example, if you are going to buy a LINAC for single energy, we can consider the cost of a LINAC to house a single energy LINAC or a multi-energy LINAC. So then on the basis of that cost, we can think that if we are able to construct a bunker for a multi-energy machine where we can house a multi-energy machine in future as well. Shielding material is very important. Certainly, we are going to design a new shielding, a new facility. Then then definitely the shielding will be with the help of concrete. But if we are going to house a machine where the shielding is not adequate, then there always comes a problem of in terms of space. So sometimes we may need to consider other shielding materials, for example, lead or other things, but then there is a question of cost as well as the reliability of those materials. Ancillary equipment in the room, it does affect the shielding calculations. For example, the ducts, those are coming outside the room, the cable trenches and all these bits. So everything in this scenario which can affect our shielding design should be considered prior to the construction or prior to design the facility. After the shielding calculation, there is a thing which is called as the facility design. So shielding calculation is one component of this facility design. Rigging, that's an important part, as I already told you. We should consider the approach to the bunker for the equipment and the patient. Base frame installation, that may affect the shielding design. For example, we have designed a facility, we have made decisions of the shielding design on the basis of putting an ISO center at a position, but if we are ending up with wrong base frame installations, so this will compromise all our this shielding study. Certainly the base frame installation will be done by the company engineer, but by the installer, but physics team is the one who are to verify the ISO center, to sign off the ISO center. So this is a critical part. And other facility requirements, electrical, civil, HVAC, and plumbing. See, all these things we can see are related to the engineers, but certainly the physics component, the suggestions and the physics coordination cannot be taken out from all these things. This is just to show you an example of a rigging design. There's a typical rigging design of a linear accelerator, what is provided by the vendors. So this should be obtained from the vendor prior to the construction. We should know the dimension of the equipment. We should not be ending up with bunkers, and our shielding calculations should not be ending up with bunkers like that, where we cannot house the equipment once it arrives. Nowadays, what we can do, for example, if you already have an existing facility and you are just going to replace a machine, or even in case of a new facility, if you already have your structural drawings with you, so you can send those structural designs to the vendor. They can put in their machines there, and they can provide you the rigging plans according to that. So this verifies that if you construct a bunker with these shielding thicknesses, so would it be okay to house a linear accelerator of this brand? So this gives you at least a comfort that nothing wrong is going to happen once the equipment is there. The regulatory approval bit is very important. PNR is our regulator. So Park 908, there's the regulation for the licensing of new radiation facilities. So recently what they have started a couple of years back, around 2 years back. So at the moment we have two types of licenses: license for the acquisition of the equipment, where you can acquire the license, import, and NOC for the import, but you cannot operate the equipment. And then there is a license of operation, which have different categories. So these licenses are like full-fledged licenses, or only for the radiotherapy, only for the diagnostic radiology or the nuclear medicine. Once you start your Approval process, licensing process, you need to submit all these requirements to the regulator. Please do comply with the what is required by the regulator, because at the end they are the regulators and we have to comply all those things. And certainly the requirements of these regulators are based on certain international guidelines, either IEA or AAPM. Sometimes we end up with things that, like, we feel that the regulator is pushing us too much, but that's the part of their job, and that is required actually. The important thing is, as a physicist, as a radiation protection officer in a hospital, we should know what are the timelines. When my linear accelerator or brachytherapy machine or CT simulator is coming up, what are the timelines? Should I directly apply for the license of the operation, or should I apply for the license of the acquisition? How much time will I need? All this workup should be done in timely fashion. And the important thing to consider all these factors is, because there is a huge amount, financial amount, that's the fee is associated with these licenses. Qualification credentials, these are the things which we considered as at the last, but these are very important things. So these should be, if we are going to start new radiotherapy service, so the qualification credentials of all the personnel working in the hospital, engineers, physicists, technologists, therapists, and physicians, this should be in line with the regulatory authorities. I myself has an experience where we started a radiotherapy facility, everything was fine, there was no observation in commissioning or otherwise, but we ended up with non-compliance of a physician colleague in terms of his or her qualification. So these things are very important. So let's start with external beam radiotherapy equipment. The first thing is the clinical need. For example, just an example, if we think that we are going to start an SRS or SBRT service, so is there any justification of the need? Are we fulfilling criteria, or are we able to provide radiotherapy services to the other population? Is this a definite need? So all these questions. So this is an important factor to consider. If we are going to start an SR or SBRT service, so what do we anticipate, that how many patients we will treat? What would be the cost of the equipment? And then there is another problem. For example, in setups like ours, we start service and then we get trainings, whereas in the Western culture, in Central Europe or in Northern America or Canada, if they have a trained physician, they have a trained physicist, they have trained RTTs, then they think of starting or developing services. So at first they get trainings either in terms of residencies or clinical observerships or the fellowships, and then they start doing things, starting things. Obviously, we cannot implement all those things here in our current infrastructure, but this is a point to think that if we are going to start a service, for example, if I am going to start a brachytherapy service in my institution, so is there any physician who is trained, who can comfortably perform implants? These are the things to consider. If we are going to start a special service, for example, total body irradiation, SRS or SBRT, so what will be the impact on all other conventional standard treatments? If we are, unfortunately, in centers like ours in Pakistan, we are very much overworked. Equipment is very much overworked. At the moment, we have something like 60 or 70 linear accelerators in the country, where the population is 240 million. So in terms of reference to the European Union Commission on Health, for 500,000 people, you should have one linear accelerator. So for a population like Pakistan, 240 million, so we definitely need something like 480 linear accelerators. Which we do not have. So what will be the effect on standard treatments, where we are treating patients from 6 a.m. in the morning till 12 a.m. in the night? If we are putting 2 or 3 SRS or SBRT patient or a TBI patient. So what would be the impact? So all these factors are required to be considered. See, all these things are very fascinating to discuss or to think or to anticipate that we will start SRS and SBRT service. We will be doing MR brachytherapy, or we will be doing this thing. That's very good. We should aim for all these good things, but these are the factors we should consider, because in doing all these fancy and fantastic things, we should not be compromising the standard conventional radiotherapy deliveries to public. And then what are the backups? That's not a problem. Sometimes we start a radiotherapy service and we do not have any backup. So we should know, we should establish MOUs or certain services, and we should think about that. We can do easily, because nowadays there are many centers in Pakistan in public sector and private sector. So I would suggest that we should have some sort of an MOU with certain centers if we cannot have a backup at our site. But the problem again is there. For example, if I am sending my patient to any other center, they are already overworked. Their machines are already overloaded. So before starting this clinical service, we should know if the machine will go down, will be out of order. What will be the strategy? And certainly the availability of the space. If I'm going to think about proton therapy, do I have appropriate space for all the associated ancillary services, including that specific service? And certainly the bunkers and all other things, etc. So on the basis of this clinical needs, we decide what type of linear accelerator we need. If we are going to start a stereotactic radiotherapy service, certainly we need an advanced LINAC, and we should justify the need. If we are going to start conventional VMAT MRT, so we need a standard LINAC with good imaging, and for 2D, 3D CRT, we can certainly use a basic LINAC. What I'm saying this very frequently, justification of the need is, for example, just an example, in my institute, we do have 2 high-end LINACs for SRI and SBRT. But considering the load of conventional patients, we can see that probably at one point we think that this is an undermining the capacity of these 2 LINACs. So spending $3.5 million or $4 million on a LINAC and just having 5 or 6 patients per month for SRS SBRT does not justify the clinical as well as the financial need of the of certain technique. So all these things are required to be considered beforehand. So if we speak about the high-end LINAC, so comes with SRS or SBRT, everyone knows unflattened or the flattened beams. Definitely you need to consider before purchasing a LINAC, what motion management strategies will you be using? So this should be in consultation with the physician, and certainly your RTT colleagues, and in consultation with other colleagues working in other centers in Pakistan or abroad. These high-end LINACs comes with the live tracking. Sometimes, so certainly, do we need those live trackings upfront, or we can add them afterwards? Everything is based on the financial values. Definitely you will need a high resolution MLCs and certainly a high precise patient immobilization system. We cannot use patient immobilization systems which we use for the standard radiotherapy, because everyone knows that in standard radiotherapy we have a little bigger margins and we have a little more room of error, for example 2 or 3 millimeters, where in SRS SBRT for high-end LINACs, this room of error should be less than 1 millimeters. And nowadays there is an era of online adaptive artificial intelligence based radiotherapy, or the offline adaptive radiotherapy. If I'm going to add a LINAC with online adaptive radiotherapy on the basis of artificial intelligence, so how many patients I will be able to treat on this LINAC? Would that compromise the treatment of other patients? Do I have an appropriate staff? All these questions are required to be considered. What would be the cost? For example, $8 million US. Maybe I can buy 3 higher linear accelerators instead of buying 1 artificial intelligence based linear accelerators. I'm not condemning that we should not move to that, but everything is directly proportional with the finances. The standard LINAC comes with the VMAT and IMRT. I would suggest if anyone is buying a LINAC for standard VMAT intensity modulated treatment, so we should go with the VMAT option directly, because VMAT requires lesser time as compared to the IMRT, especially in centers like us, where after every 10 minutes we have a patient. Machines comes with the standard MLCs and certainly electronic portal imaging devices or the KV imaging devices. If we are going to buy a Linux, we should definitely consider KV imaging that is with an addition of cone beam CT. If we have the finances. And the basic Linux comes with the blocks or the MLCs with or without electronic portal imaging device. Please do not assume to what you don't have and just stick to what you have. Nowadays vendors are giving us a lot of different things. For example, one company is saying that we will be launching this robotic couch very soon. We will be, providing this software version very soon. So if you are going to purchase the LINAC this year and you are working at this moment, so just stick to what you already have and what is commercially available in the market, and do not think or assume what you do not have at the moment in the market, because we do not know the bugs and the consequences related to that equipment, because it is still unveiled. So not built. So that's the reason we should stick what is commercially available at the moment while we are purchasing an equipment. And certainly we should try to buy as latest as possible. I mean the latest version. If we think about the imaging equipment, certainly there is a choice of CT simulator. In certain centers, there is a dedicated CT simulator for the radiation oncology, and there are many setups where the CT scanner is being shared with the radiology department. So then we should think what bore size is required and the number of slices. It does matter, it does not matter. If you have a dedicated CT simulator for radiation oncologies, you may not need that. But certainly if you are sharing your CT scanner with the radiology department where they are to scan something like, say, 60 or 70 patients every day, definitely this number of slices will depend. Imaging equipment, all these things written on the left side of this picture, basically everyone knows very well about that, but I'm just going to tell some of the tricks and the tips. The compatible tabletop. The tabletop should be fully compatible with the linear accelerators. Sometimes it becomes very difficult. For example, in my center, we have 5 linear accelerators, 4 of them, and 2 dedicated CT simulators. So 4 of the linear accelerators are compatible. The couch tops of 4 of the linear accelerators are compatible with 1 of the CT scanners, and 1 of the machine, the linear accelerator has different couch top, and then the second CT simulator has a different couch top. So sometimes we end up issues like that. So we should avoid it as much as possible, but you may end up with scenarios where sometimes this is not possible. We should try, but at least we should try that the tabletops should be fully compatible. Immobilization accessories, try to make it as uniform as possible across all your radiotherapy machines. Moving or static lasers, they should be fully integrated. They should be with your treatment planning system and should be automatic. If you have a 4D capability in your CT simulator, so please ensure that this 4D capability is compatible with the this respiratory gating and this 4D capability is compatible with your treatment planning system and with your machine. Some of the vendors are offering 4D capability on their CT simulator, which just lies on the console of the simulator. And while transferring your data bins, 4D bins to the treatment planning system, we need to do a lot of manual works. And that's a huge risk of error. So this is one point to consider, that the 4D capability of the CT simulator should be fully compatible with the treatment planning system. The same is the compatibility of the respiratory gating system. Certain CT scanners, they do have the respiratory gating, but the time amplitude curve is not compatible with the curve of the machine. So the treatment planning system requires to generate a new curve for that, and which is a big source of error. And then the software for the virtual simulation. Some of the vendors are providing virtual simulation software for their CT scanners for themselves. And see, you can integrate everything, but certainly if you do not have a closed system, there is always a risk of errors. So this, if this virtual simulation is lying, this software is lying on the console, and we have a different treatment planning system, we may end up with some compatibility issues. And the integration of the treatment planning system, that's very important. Certainly, if we are not in a position to buy a CT simulator and we are going to do a 2D radiotherapy, so fluoroscopic simulator is required. We can have it with or without digital imaging. So linear accelerators. We know there are many vendors available. You can see the names of 2 of the vendors in this picture. So without hiding anything, there are 2 big competitors at the moment in the market, and there are many FDA or non-FDA approved other equipment from Asia Pacific and Central Europe as well. So at the moment, these are the conventional shapes of linear accelerators with single or the multi energies. But nowadays, there are few other linear accelerators coming up with new type of with new shapes. These are somewhat compact in terms of technology and do require less shieldings, but they do have their own pros and cons over the conventional LINACs and one over the other. So how to choose? That's an important thing. How to choose an equipment? So either we are to choose a conventional LINAC or we are to choose these newly available compact LINACs. If you are going to start a radiotherapy service and you have enlisted few things, for example, I will be treating patients with 3D, I will be treating with patients VMAT, and I will be treating patients with electrons. So certainly you need a multi-energy LINAC where you can treat 3D patients with high energies where required, for example, prostate, gynae. And if you are treating patients with VMAT, the machine should be should be of the capability to deliver VMAT. And if we are having a lot of skin patients, so certainly electrons are required. So we will be ending up with a conventional LINAC. If we just consider to go all the patient with a standard treatment for single energy VMAT, and we do not need any patients to be treated for superficial radiotherapy, so certainly we can choose any one of the this newly designed LINAC. So all this is based on our clinical need, what is required, and what should we opt. And certainly cost is a big factor. How to choose a vendor? That's an important thing. There are multiple things to discuss. The first thing is the cost. Truly speaking, many of the vendors, they do have the cost comparison, something like within a ratio of 99 and 100. There is no gross difference in terms of cost. But obviously, the bit comes, for example, if a center is having a 4 or 5 LINACs from one vendor and they are going to buy another 5th or 6th Linux from the same vendor. So they do have a different type of financial contracts with that institute. In comparison, if someone is buying a Linux first time from them, if someone is having equipment from a vendor, 2 or 3 Linux and want to add another Linux from a second vendor, so they may be giving their cost in respect to all these things. So cost is an important thing, and we should not compare cost, and we cannot compare cost of one of the Linux being sent to one institute with the other institute. Certainly, the costs are fixed. For example, if a price of a LINAC is something like $2.5 million, that's the price of the LINAC. But what is the financial agreement to one institute? This cannot be compared with the financial agreement with another institute. This is one thing. Then definitely there is a features availability. Some of the vendors, they have different features and the other vendors have the difference, but one or the other, they do all have same sort of features available. Some of the vendors, they are manufacturing single energy Linux as a dedicated Linux. Some of the vendors, their Linux does not fit, may not fit in a facility you already have because of the smaller rooms or rigging plans. And then the last thing is the maintenance and the support. The maintenance and the support is always a question. Because the few things we think that the maintenance and support from the company side is not of the level which we actually anticipate and we expect. But since we are living in a country where there are few other crises, for example, there is no principal representation of the vendors. There are no warehouses. And it is not possible even for the vendors to have their warehouses in Pakistan sometimes. I have spoken many of the principals of the vendors. So because of the country's legislations and the regulations, few things are beyond their scope even. So, but certainly the maintenance service and the support comes into existence while deciding your linear accelerator on the basis of a vendor. All manufacturers, they produce products at their best, and we have to choose which is best for us. That's the last thing. There are certain equipments, they are for dedicated techniques, for example, SRS or SBRT. If I'm going to buy a cyber knife or a gamma knife, so certainly there should be a clinical justification, because then I cannot totally treat any conventional patient on this clinic. That would be very difficult. So how many dedicated patients are ending up? Am I going to develop a dedicated radiotherapy department for this for dedicated radiotherapy service? For example, a radiotherapy department which is just offering SRN and SBRT service, then we can consider that. And certainly the cost efficiency is an important thing, which equipment to buy. Some of the equipments are radioisotope based and some of the equipments are linear accelerator based. The maintenance, the cost, the maintenance and the purchase. So everything is based on cost. Treatment planning system. We can have a treatment planning system for external beam. We should have a treatment planning for external beam and the brachytherapy. Should that be from one vendor? I suggest yes, should be from the same vendor. But sometimes we may end up with a situation where we cannot have a treatment planning system from the same vendor. So that's not a problem, but we should know that this treatment planning system should be integrated with all the equipment. We get one liberty once we purchase the treatment planning system, which is integrated with the equipment, that the system is in a closed loop. Whenever we buy a treatment planning system, which is from another vendor, and we have another vendor for the equipment, then we always end up with open loop systems. So there may be a risk of errors. While giving orders, we should know what is the latest possible software version we can have. So that's an important thing. And we should stick to buy the latest available software version. Definitely, we need to decide on the basis of our workload, how many contouring or calculation workstations do we require for us, for our physician colleagues, and for the for other um, uh, for other radiotherapy technologists as well. Do we need an appropriate specific networking for this, dedicated networking for this treatment planning system? And what would be the contract for the upgrade or the maintenance of these things? May I request Mishkat Bhai, please mute your mic. Thank you. So while buying a brachytherapy equipment, we definitely need to know and gather the information, what are the clinical need, what will be the anticipated workload, because again, this is the $6.6 million equipment. Do we have an appropriate procedure room for that, where our physician colleagues can perform full-fledged infection-free procedure about the shielding of the treatment wall? We will be sharing a shielded room from the LINAC or the CT simulator, or there will be a dedicated vault for the treatment. Choice of the equipment, definitely. Nowadays, everyone is going towards the HDR, which is the sensible choice. And the choice of the applicators. We should not be ending up by purchasing applicators we are not going to use in next 10 years. And this is something which is totally based on the clinical sites you are going to treat, and this should be in consultation with the physician colleagues. Integrated treatment planning system, certainly with the external beam, where you should be able to add your external beam radiotherapy plans with the brachytherapy plans. Radioisotope replacement, the contracts, either you will be, for example, if it's an IR 192 based brachytherapy, so either you will be replacing your source twice, thrice, or 4 times in a year, and certainly a trained physician and a physicist before starting this service. When we speak about the quality assurance, the first important thing is, please list down all the modalities which you have at the moment and which you are anticipating in near future, and then write down the QA equipment required for all those modalities. So we know there is a requirement of machine specific QA, and then there is a requirement of the patient specific QA. We all know that if we are going to have a linear accelerator, good linear accelerator, certainly everyone needs a 3D water scanning system. And definitely we need a set of ionization chambers for absolute measurements and scanning, and certainly the electrometer. This is the minimum thing we need to do for the scanning and the absolute dosimetry. If you are to start service for SR and SBRT, certainly you need a small field dosimetry. Small field dosimetry chambers are very expensive, so you will be requiring chambers for the machine and the patient QA. You will definitely need a set of chambers for all these things. What would be the calibration of ionization chambers? Because at the moment, certain type of ionization chambers, we cannot get calibration of certain type of ionization chambers here in our country. So we need to send those chambers to the vendor. That's an important thing to consider. Would we be able to have calibration of those ionization chambers in future? What would be the backup if I have one former chamber, and for God forbidden, if this is broken, what would be the scenario then? So we should be considered and should be prepared ourselves for these backups. Certainly the vendors, if we have a water phantom from one vendor and we are having a chamber for another vendor, so would that be compatible? So the choice of vendor is very important in buying all these things. And backup, sorry, I have written it twice mistakenly. If we are performing an MLC QA, do we need a 2D array or a portal dosimetry? There has always been a debate about that. So you can have a 2D array for the MLC QA, but certainly this is a time consuming. You can have a license on your portal dosimeter, but that will cost you a little more than the 2D array. So you need to decide yourself about that. If you are performing MLCQ in a 2D array, this is an independent thing. This is one factor, but you are ending up with 45 minutes or 1 hour for a MLCQA on a 2D array. If you have a portal dosimetry, you can perform your MLCQA maybe in 10 minutes, but this is a cost. This is something which requires a cost, and this is something which is not an independent. It's from the same vendor. No literature at the moment says that you cannot use a system for the QA from the same vendor. Yes, there is always been an instinct that this QA is being done on the device from the same vendor, but there's no recommendation like that you cannot use. So I would suggest that in a setup like us, where we have less colleagues in physics, a lot of work to do. Even the treatments are being done on Saturdays and weekends on the machines, and we have less time to do our QA work on the equipment. So if we have a choice, we should ease our life by doing the portal dosimetry. Otherwise, what we will be doing that if we buy a 2D array, I have a cost, but I have finances, but I have purchased a 2D array. It will be taking me so long that I will be ending up by not doing QAs. So make your life easy and make decisions amongst different things as per your need. And certainly you need if you have an electronic portal imaging device, you should have an electronic portal imaging device QA Phantom with certain software to check the spatial resolution, noise, and all other things, image quality, and all other things for your electronic portal imaging device. For the CBCT, most of the mechanical tools, those comes with a machine as well. You buy a machine from Variant Medical Systems or buy a machine from Electa. Many of the mechanical tools, they comes with the machine, but certainly while finalizing the specification sheet, as a physicist, we should ensure that all these things are included into the contract. You may need to buy certain imaging QA tools, and certainly we should perform a dose QA while measuring the KV and MES values. There are always a problem for the dose QA of the CBCT. The meters being used, being purchased have calibration issues, like we do not have any calibration laboratory in Pakistan. So every time we need to send these to the vendors. So it takes about 3 to 4 months to get them calibrated and to get them back after every 2 years, and it involves the cost a lot. So the main theme of this slide is that if we have an equipment, for example, if we have MLC, if we have IPIT, if we have CBCT, we should definitely have a QA for that as well. We should not be putting these machines into clinical use without QA. If you have an ISRS SBRT service, an end-to-end QA system for CT/MR compatible is must. Again, if you are to check the patient dosage, either you can, and you are doing VMAT based SRS SBRT, so either you can purchase a 3D array. That would be an independent solution, but that's a time consuming. Setting up a 3D array and then getting results will end up something like 1 hour job. If you have a portal dosimetry, it's a cost thing, but this is very easy. You will be getting results in maybe in 10 minutes, but this is not an independent system then we need to make choices by ourselves. And certainly we need small field dosimetry system for the patient QA, where we will be checking point doses at different points. If we are having a standard LINAC VMAT and IMRT, again, 2D or 3D array is required and border dosimetry is required. If we have a dynamic or the virtual wedges on the machine, I'm sorry, I have just written it in virtual dynamic MLC. That's the virtual dynamic wedges. So either we need a 2D array for the QA QC of the dynamic wedges or the virtual wedges, or we can use our portal dosimetry. For the CTQA, definitely we need a CTDI, KVP, and MES measuring system. Again, there are certain issues of not having calibration within the country. I have been told by the PINSTEC that in near future, they are coming up with the calibration services of these KVP, MES meters and the CTDI measuring ionization chambers. And certainly you need a CT density phantom to verify your curve with different holders of different densities to generate Hounsfield unit values and attenuation factors for your treatment planning system. Most of the brachytherapy equipment comes in contract with the machine itself, but certainly we need to verify that this is a part of the contract. So that is something like wild chamber and lactometer. Again, at the moment, there is no calibration laboratory available in Pakistan. So we need to send those wild chamber and lactometers to abroad for the calibrations. And certainly few other checks like 12 step checks and QA for the QA applicators. One type of the QA is the fluoroscopic QA, and the second type is the physical QA, which is the length measuring device, length measurements and dummy verification. So we get length measuring devices and dummies for the verification for QA things. If we have a respiratory gating system, need to measure a dose measurement that requires a moving platform in the phantom and the verification blocks. So we should consider that if we are going to buy linear accelerators with certain modalities, we must have all this associated QA with us. Putting a machine into a clinical use without all this QA QC is not worth it. It's not suggested actually. And certainly you need a QA devices for your daily quality assurance. At the start of every day, you need to check the output of your LINAC. You need to decide either you need to buy a wired devices or the wireless devices. Nowadays, a lot of beautiful wireless devices are available. I remember 20 years back when I started my career, so we were ending up with putting wires into our Cobalt 60 unit and linear accelerator bunker every day was taking us around 30 minutes on one machine. So nowadays these wireless devices are very beautiful. It just takes 5 to 10 minutes to get your output checked. Then there are few automated tools available for the daily quality assurance on the machine. For example, Winston's test for SRS and SBRT. So if there are two choices, either we should buy an automated tool on the machine or we should buy another independent tool for the Winston's test. Again, there are three factors. One is the cost, second is the independency of the test, and the third thing is the time. So we should consider all these factors while very carefully while choosing this equipment. This is an image from the courtesy of American Medical System. Third-party independent patient dose calculation quality assurance is very important. That's an independent treatment planning system. So there are two things. Again, either you buy a independent treatment planning system from the third party. This you may end up with the time factor. For example, if you have a treatment planning system from one vendor, you have an independent TPS from the other vendor, you need to export and then to import images or the plan into the other treatment planning system, and then you need to do the time calculations. So this may be a time consuming, but the plus point is this is an independent system then. Nowadays, vendors are making independent systems, and there's the same vendors are making system and they are calling it as independent system because they are not putting them into a closed loop. So, but again, still there are questions of the reliability. These cost a little more, but these are less time consuming. So this is something you need to choose in terms of your setup, that how many patient QAs you are to perform, to check independently in a day or in a week on, and what are the financial resources available to you. Then you need to decide what you are going to have those. So the known issues are always the compatibility, multiple vendors. Some of the systems are user-friendly and some of them are not user-friendly. Service and the maintenance, and definitely the availability of the parts if the machine is non-functional. Trained engineers, either you have a contractor, you have an on-site engineer. Equipment stability. You may have a machine, for example, in my experience, we have a machine from a vendor which worked very well with us with a 99% uptime for 18 years. We had an upgraded and a very advanced version of the machine from the same vendor, but the machine was the uptime of the machine was less than 95% in first couple of months. So it is sometimes it is an equipment dependent thing. Obviously the patient loads, if we are treating 100 patients, running our machine 6 days a week, then the machines may require, and we are treating long working hours, running machines for long working hours. So the probably the 4 preventive maintenance inspection in a year would not suffice the need of this equipment. So this will put us in a position that we should be ending up with doing corrective maintenances, or we will be ending up by increasing the frequency of the preventive maintenance, for example, 4 to 6 or 7, and then certainly the trained staff. So what am I supposed to do? I should develop requirements and specification for the purchase of an appropriate equipment. And I should design a facility. I should monitor facility construction. Certainly this is not our responsibility while they are constructing what we have already provided, but we are the one we can see that what we have proposed is not being done appropriately. And this is the time where we can get things good, make things rectified. Otherwise, once it is done, it cannot be redo or cannot be undone. Perform acceptance testing, commissioning, trainings, and quality assurance programs. A few slides about the installation and the commissioning of the radiotherapy equipment. Certainly, this is the responsibility of the licensee. Some of the hospitals, the licensee is not a physicist, either it's a chief executive officer or the medical director or the director of the hospital or any other administrator. But you are the one. Physics is the one. They are to answer every query. So directly or indirectly, we are responsible. To supervise the installation and commissioning, we should have a strong clinical physics background. We should have a capability to lead. And if we do not have anyone with strong clinical background or have not been a part of any previous installation and commissioning, then there should be someone who need to supervise directly or indirectly. And someone who is responsible for the installation or to supervise the installation and to perform the commissioning of a machine should have a training of certain level. We speak about the linear accelerators and treatment planning system. The first thing is please do prepare at the first. So because the preparation that saves your time, list down things and make a Gantt chart. It helps you understand that what actually you need to do, and then you can certainly mitigate your risks. And if you have a timeline, you have drafted few things, you have made appropriate preparations, and it is written somewhere. So if you have done something, if something happened unexpectedly, so you can recover it quickly. So the first thing is to draw a timeline. This is an example for a LINAC, of a high-end LINAC. The installation, that timeline will come from the vendor. Typically it takes 2 to 3 weeks. It does not include the base frame installation timeline. So installation of the machine, the acceptance may take 3 days to a week, and then the commissioning, that's the physics call, 4 to 6 weeks or 8 weeks depending on the type of the LINAC, and then at the end the final check, it takes 1 week. But in order to perform this, I should these are the few of the keys to do commissioning. So I should not be over smart while performing the commissioning. That's the first key. Because one small mistake can lead errors in calculation of millions of patients. And we should be optimistic in timelines. with margins. For example, if I think that I will be able to conclude my commissioning and the machine will be ready for the clinical use in next 4 weeks, so I should keep some margin. So to telling to the management that I will be ending up machine in 4 weeks, they will say, why can't you do it in 3 weeks? So I will be ending up with some problems. So for the reason, I should always keep some margin for myself and should tell them something like with the time span of 10 or 20%, but not unwanted delays. The unwanted delays comes, for example, I know that the commissioning of my machine is expected in the month of December this year, and I have this information beforehand. But what I'm doing, I'm just going on my annual leaves in that period, which is not good actually. So typical schedule of event, I'm not going into the details. That's the construction that we have already discussed. So construction and installation, physicist is a part, and certainly the administrator is responsible in execution of this construction work. Acceptance testing is purely a physics job. Commissioning is a physics job, and the go live, that is the physicist, physician, and the RTT is trainings, and then the go lives we treat first patient. In constructions, sometimes these are mostly handled at some places by the facilities or by the vendors. We have already discussed all these things. In the planning phase, we should consider everything we have already discussed. So while there is an actual construction going on, so please do visit the site very regularly and keep photos or references for your future record. Base frame installation, as I already said, there's an important point. Correct position of the base frame of the ISO center. It may affect the shielding, it may restrict the machine movement, or it may affect the other room logistics. Installation is performed by the vendors, and we should just observe and supervise all these necessary bits, and we can learn the components from the engineers, what they are doing, and certainly we can have the information what are the possible delays. Acceptance testing is basically is a procedure where they demonstrate us, the vendors demonstrate us that what we have actually purchased. So this is an important document to sign. So if we are signing this document, means that we have accepted the machine. So we should be very careful while signing this document, and unless or until we are assured that all the specifications are met as already agreed upon. And as a rule, we should not be accepting our machines at marginal values. For example, this is an example. The tolerance for a gantry is 1 degree, or if we are ending up with values in acceptance 0.9, so we should certainly ask the engineer to bring this down. Otherwise, what will happen, the moment he will fly back, my value next day, my value will be more than 1 degree, and I will be ending up with troubles at the start of this problem. Acceptance testing, we need to, there are a few tricks and tips to see. We need to have a detailed look into the machine, equipment, physical verification of all the things, of all the physical and the logical things. In my career, I ended up with a machine where we purchased an energy that, and what was provided was different. And certainly we need to verify the ancillary equipment, software versions, what was ordered and what we have received, and certainly the integration with the hospital. You are responsible for the commissioning of a LINAC. You have not done this before. The project has started. Everyone wants to know, when are we treating the first patient? So this is a typical scenario. We end up this. We should not be in a hurry. So the commissioning phase, so basically the clinical medical phase is that is the system for the stable and the routine clinical use, and then validates the availability and the proper function of the feature. We all know that. So there are two types of commissioning, dosimetric and the non-dosimetric commissioning. Dosimetric commissioning is everything we know, that what we need for our treatment planning system and to do the patient calculation. And the non-dosimetric things are The other things, for example, to set up patient immobilization devices, to make certain policies and procedures, to make certain guidelines, all these things comes up in a non-dosimetric scenario. But certainly in order to commence a clinical service, we need these non-dosimetric services as well, in addition to dosimetric services. There are a lot of IAAPM reports where we can have all these things, peer-reviewed journals and publications. I would suggest if someone is going to start commissioning, so they must read at least these 4 major documents: TRS 483, which speaks about the external beam dosimetry, recently published AAPM report on TG 155 on the small field dosimetry, and then, you know, 2 golden reports, TRS 398 and the TG 51. So everyone who is going to start commissioning first time should read all 3 or 4 reports stringently. While we are commissioning an equipment in an existing facility, we should consider that how many personnel are available for commissioning. Because if we are going to install a machine in an existing facility, so other clinical work is in process. So, and then we need to discuss things with our colleagues that no one is going to vacations during this time, and there is a possibility that we will be ending up with early or late shifts. So all these arrangements should be beforehand. And before the start of commissioning, those things which are required from the facility side must be in place as well. Before starting the commissioning, we should list down all the available required equipment and certainly the functionality. If we have already given a timeline to the administration to start our clinical service, and today I am going to put my water phantom and I can see that my ionization chambers are not working, so that would put a very bad impact. So we should check the functionality beforehand. Beam data requirements, they are very standard. There are certain standard requirements, and there are some specific requirements. Those are specific to the algorithms, and those are provided by the vendors. And we should read all documents very carefully. Otherwise, what will happen? If I have not read all those documents, I have started my measurements. At the end, I may need to repeat all these measurements, which will be a time-consuming and waste of time. So it is strongly recommended that 2 persons should perform the measurements. It does not mean that if someone is very experienced, so he can perform the commissioning independently. Yes, he can perform the commissioning independently, but there should be another second eye to verify the things, just to cross-check. For example, if I have received a value of 67.5%, and if I have written it mistakenly 77.5%, that will make a hell of difference. Or at least there must be a direct or indirect supervision of the work, because we know that in many places there are unavailability of persons more than one. So at least there should be a direct or indirect supervision. This is just a typical example of courtesy of Indian medical systems, so that beam data requirements from the AAA or the Accurus. So just to show you this slide that we can have all the specifications of the required for the beam data for the algorithms from the vendors. What is the rationale of commissioning beam data? We can have a golden beam data. Yes, we can have a golden beam data, but sometimes the golden beam data and our beam data does fall in an appropriate, acceptable window range, but we may not be able to, because of the specification of the machine, we may not be able to, and other resources, we may not be able to achieve or to carry it for long. So it's good to have a machine commissioned for. Certainly, if you have 2 machines, 2 sister machines in your institute, you can commission 1 machine, then you can compare the second machine with your data, and your first machine data will act as the golden beam data for your second linear accelerator. Few things are required to establish while performing commissioning. We need to define the nomenclature of the data. What will be the names of the files in order to make things uniform? Scanning type, either we are going to perform all the dosimetry on the continuous mode or the step mode, but we'll be keeping the scanning speed, step size, smoothing, etc., etc., etc. And it is highly recommended that someone should check the setup independently. This is highly recommended while starting your day for commissioning. We should know the limitations of our ionization chambers and other dosimetry equipment. For example, it's a small thing, which is a connector. I myself ended up with an ionization chamber. We were purchased an ionization chamber of 2,000 euros, and we ended up with a wrong connector, and that was ordered probably wrongly from our side. Then we need to find out the possible setups and errors. We need to keep an eye of all these things during commissioning. Choice of detector orientation, that is an important. We need to establish this while doing the commissioning. Scanning speed, as I already said, we need to establish these things. It affects a lot. And smoothing. So all these things we need to define or to make baselines while doing commissioning. And all this you learn from experience, and you need it to do a lot, and sometimes you need to perform things multiple times to get your desired result, and it requires patience. We should understand the limits of the and miring conditions. What is the size of my water phantom? What is the largest field size I can scan? So we should know all these things. If I am ending up with data which have unusual data set, for example, the PDD of 6 MB is 64%. So I should question myself, what is this unusual? I should consult someone. And then please do write notes for future references, because next year you will be performing the annual quality assurance of this equipment. Always perform double check of the beam data through comparison. You get data from colleagues, vendors. There is an international available data, and you just compare your data with that data and perform verification on the closed or the open ends. Few slides about the HTR and the CT simulator. For the HTR brachytherapy, as I already said, either it can be a dedicated vault, can be shared with a LINAC or with a simulator. If I have a dedicated vault, definitely that will cost you further, but you have a space and you have a dedicated place to treat your patients. If you are sharing with LINAC or simulator, definitely this will reduce the use of both of the other equipments. Acceptance testing, the commissioning of the HTR unit is quite standard. So we need to check the safety standards. Either we are meeting the contractual specification of the units, and certainly other parameters which were agreed upon. And the commissioning is the end-to-end test and all the required test, training of the staff and development of the quality assurance procedures. But do we need to know about the QA, QC and acceptance commissioning of the HDR? So these are some of the references. For CT simulator, certainly we need to check the software integration with the treatment planning system. For example, if I have coordinates on CT, so we should have the same coordinates on the treatment planning system. Sometimes this is the -X on the CT is the +X on the treatment planning system. So we may end up a lot of errors or risk maybe in future. Integration with the laser system, certainly integration with the existing treatment planning system. Obviously, there is a need to perform mechanical tests before putting CT simulator into the clinical use. Image quality, a lot of tests are required before putting the CT simulator into the clinical use, and then definition of the protocols for different clinical sites based on those reference levels provided by the international associations or our national regulators. And then certainly we need to establish baselines for the CTTI, KBP, and the MES. So the conclusion is that all new radiotherapy equipment must be evaluated against the specified recommendations before clinical use. Clinical and QA SOPs and policies must be drafted and approved before start of service. That is very important. So please get all these things approved before clinical use. Regulatory approval must be in hand. If you do not have even a provisional equipment, provisional approval from the regulator, please do not put your equipment into clinical use. Staff must be trained. This is an again very important thing. We should not put our patients on risk while being handled by untrained staff. Safety of the patients, public, and the workers should be attained while using this equipment. And third-party verifications should be done before clinical use. For example, if there is any requirement of beam output measurements voluntarily or by regulatory, these should be done before clinical use. So thank you very much. This is all from my side. I know there are a lot of different things to consider this, but these are few things which I tried to make it myself. So if there are any questions, I
Thank you
can
very
see.
much, sir, for the informative talk.
Thank you.
Participants are requested to ask questions.
Okay.
They can unmute their mic and they can ask the questions. We have one question in the chat box. It's kind of comment and also the question that take-home message I got from your talk is the physicist is responsible for most of the work, but the question is who is going to decide that the site physicist has all the credential to do this? Do you think that the regulatory or independent certifying body should certify the physicists to do this work? Otherwise, who is going to check that the physicists are doing the right job? So any comments, sir?
Yeah, so true. There are two possibilities. So in countries or in regions like in Central Europe or in America or where there are certifying bodies, they can certainly certify the physicist. Remember, regulatory bodies never certify a physicist. They are the regulatory body. They can check the performance of the equipment and the competency of a physicist against the standards which are defined by a certain certifying body. So the role of a regulatory body is beyond this scope. Yes, certainly there must be a certifying body who can assess and who can check the and who can perform the competency assessment of a physicist. But unfortunately, in centers or in a region like here in Pakistan, we do not have a certifying body. What we can do here is that institutions should develop a competency assessment for the hospital, for the physics team, and that should be evaluated by certain qualified physicist from abroad, maybe, or if there is someone who is board certified or already certified, he or she can perform the competency assessment of the colleagues against certain parameters and can then, yes, certainly let the team do this. So yeah, unfortunately, there is a dilemma in certain centers. There is no one who is already certified, but there's again a responsibility of the institution that the patients and patients should not be handled by untrained staff. So if they are hiring a physicist, the hospital or the institution, either it's a public or the private, there should be mechanism of the competency assessment of their staff through certain body or through certain other physicists, maybe. Like for example, in our hospital, Shaukat Khanam, we have a competency assessment thing by certain already certified staff. So for those who do not have a certification, though through a certain certified body, their competency assessment is regularly done by the already certified staff in this way. Anyone else?
Any other question? Or the participant can also share their experience in the hospital for the hospital management and the regulatory while they are buying a new equipment. So they can also do discussion as well if they want to.
True.
Hello, Rafaye. This is Kashif from GM.
Yes, Dr. Kashif.
It was really a great session today. At least for the people who are new in this field, they may have got enough knowledge how to proceed in a new radiotherapy department. So I'm very happy for this presentation today.
Thank you very much.
I have a comment and a question. My comment
Yeah.
is related to certified clinical medical physicists in Pakistan. We have no idea when we will be able to get those. Whichever we have, they are all either ABR